proud of is that a book came out about 4 months ago, and it's embarrassing that I'm not remembering the name of the author, but it was a book for people who have just had stroke, but I do remember the title, and it's a book called Stronger After Stroke.
Okay.
The title of the book is Stronger After Stroke, but he asked me to give the book an endorsement, which I of course was happy to do, but then they put the endorsement right on the front cover with my name. So on the front cover of a book for patients, for sufferers, called Stronger After Stroke, is an endorsement right in big font on the front cover. So that, I mean,
I think your work could be applied to numerous different aspects of healthcare.
Yeah, exactly. I mean,
not just stroke and Parkinson's.
Yes, exactly. But Taub, you know, did all this work on stroke. But okay, so here's the issue with cardiovascular. I mean, I thought a little bit about this, and I could say it to you in reverse. It's not my field at all. Yeah. But obviously, you got all the sodium and potassium in the pumps and and it's all the same thing applies. So yes, the state of the heart, you know, is also obviously this is very good for, you know, the whole Herb Benson kind of mind, heart, cardiovascular, you know, connectivity, and way beyond that, even at, you know, levels of very significant complexity. And he's now actually published this paper not too long ago, and I have it in my computer so I could actually and it was published in PLOS last year, a study showing that the genetic expression of enzymes linked to oxidative phosphorylation have a significant change in their expression in people who just practice this simple relaxation response that he's been doing for, you know, decades. And so all of this reasoning absolutely applies to what you might call the action templates of the electrodynamics of the heart.
Sure.
And it's going to influence things like atherosclerotic plaque formation, et cetera, et cetera, et cetera. Absolutely.
Well, you talked about calcium channels, and
exactly.
So I was thinking about calcium channel blockers and the treatment of arrhythmias, for example.
Okay, that's perfect. I mean, again, I'm just talking like, you know, I have not much more than literally a lay understanding of the heart stuff. I mean, but there it is. We all know that states of emotion, states of mind, have influences on cardiac arrhythmias, especially in people who have vulnerabilities, yes. Right? And obviously the whole issue of relabeling and emotional control is something that now, it's taken a long time and they're still not really at the forefront, but there's at least the beginning of the acknowledgement that it might be worth training people who have cardiac arrhythmias to control certain kinds of emotional responses, because if they do that, it's going to, decrease their chance of having a serious arrhythmia, etc.
So you must be excited about all the research into mindfulness meditation, which NIH is supporting.
Okay, well, that turns out, yes, but I have to say, okay, so where's the ambivalence come?
Yeah.
The ambivalence comes from, as I've been referring, they will not touch the theoretical implications of what they're doing. And if you present this kind of work within a materialist frame, not only does it undermine the quality of the training that you can do, it almost becomes a tool to work against what you're really trying to accomplish. Because, I mean, I'll just give you a really fast anecdote. One of the main researchers in that field, and he is a very good one, and I met him in Germany last summer at a conference, and I was really looking forward to meeting him. And he had done and I was involved in Vipassana Theravada meditation for many, many years. And he did a study that was also published in PLOS on what he called attentional blink, and the influence, which is a well-known physiological thing, basically a study showing that people who had been trained in Vipassana meditation, it was so supportive of what we're saying about attention density. I was really excited that to meet him and everything. And he used to be, I'll say this much, he was a postdoctoral fellow of Varela. So that's a name I can mention, okay? And Varela had the same issue that I'm about to say. The study was, in my opinion, very well done. I was very impressed. And it seemed to be very supportive, because he's basically showing that using basic psychophysiological measures that are not very controversial and that are well accepted, that the spacing of attentional focus is more dense. There's less attentional blink in people who had been previously trained in Vipassana meditation. Mm-hmm. And then he even took people and did it prospectively, where they trained them in... Okay, I meet this guy to make a long story and a very long discussion very short. I could not get him to acknowledge that anything about anything that people were doing willfully with their attention had anything to do with the data that he had collected. I said, wait a second.
Isn't that a paradox? What's his rationale?
Paradox is a polite way of saying what it is. And I mean, so he was sitting, and he actually got all, I said, but you seem to know so much about Vipassana meditation. I mean, and he said, okay, I like my research to be well done, and I learned some things about Vipassana meditation, but from talking to you for 15 minutes now, I'll tell you right now, you're probably assuming I know a lot about Vipassana meditation that I don't know. I just learned enough to do this study, and I don't know anything about the philosophy that underlies it, and I'm not even interested in the philosophy that underlies it. The only reason I studied this is because I'm finding that it causes brain effects, and I want to generate brain effects to study. And I said to him, so wait a second, you think that your study is really just at the bottom line, a demonstration of the brain doing something to the brain, and that mind and attention has nothing to do with it? He says, that's right. I'm not interested in the mind, and I'm not interested in attention. I'm interested in how the brain changes. And I believe that all the causation in this study is a result of the brain doing something to the brain. That shook me up. And I'm not saying that everybody in the field is like that, but he's one of the best. In fact, among the researchers, I'll say he is the best. That's my opinion. He's good. And even the people who wouldn't go there because they're not even philosophically sophisticated to make as assertive a statement as that, at least he's making an assertive, informed, he's assertively defending a materialist position in his statement. But all the people involved in that field, it's all like, whatever, it's like touchy-feely, it's like this. It's not all, I mean, if I could get Cresswell, this is what I'm saying, if I could get Cresswell, Kirk Warren Brown at VCU, the guy who's devised that scale, that's a guy, he's not a brain guy. He's a psychology guy. He's a psychometrics guy. He's on the other side of this debate, but people just don't want to engage it at the level where I think it really has traction, which is it's not just about the brain. They're just trying to do it at this, you know what I'm saying? I mean, they just won't go to where it really has traction. And you're not going to change, you're not going to get systemic change in the philosophy of healthcare by just making mindful awareness seem like, the next thing in materialist medicine. But, like they always say when you talk to them, Jeff, I like to get funded. And if I say what you say, I'm not going to get funded. Mm-hmm. But it's a free country. But it's a free country anyway. It's a free country anyway.
I have to say I was a little surprised when you said that NIH doesn't support this. So
they don't.
You're dancing around the politics, I think. So is it because what you're suggesting is that we do have control over what happens? And
I don't want to get carried away. We have influence over what happens.
Right. And if we have influence, we might not need to be so medicated?
Amen. Amen. From your mouth to God's ear. How about it?
All right, so going back more into the quantum physics side of this, you mentioned that within the quantum physics community, there's a sect that is trying to leave out the consciousness out of the mathematical equation. What would their arguments be, and what are their thoughts on the connection between the quantum Zeno effect and ion transport?
Now that's the question.
All those mechanisms.
That's the killer question.
Physicists, start their training in classical mechanics, and they bring a lot of momentum, basically from classical mechanics, and this philosophy, the approach to quantum mechanics that was espoused by the founders of quantum mechanics, they saw it really as in the way I've described it. In other words, it's really about, science itself is really, at the end, about our observations, our experienced observations, and how our observations stick together, and how we can use, how we develop theoretical ideas for making predictions about relationships between conscious experiences. And so that's where the founders of quantum mechanics went. And basically, as I've been describing, it's about, from that point of view, it's about experience. And now, that all happened, in the first half of the 20th century, basically, and the first 33 decades, actually, a lot of it had already happened. So then time goes by, and the philosophy people kind of forget about, and in fact, if you go to physics courses, you never hear any about this. Really, the physics courses just teach you really this philosophy, but they don't say it. They just say, here's how you do the calculations. There's an expression, shut up and calculate. I mean, don't ask these questions, just here's how you calculate how to make a prediction about what your experience is, what the result of an experiment will be under certain conditions. So there was kind of a reluctance by a lot of physicists to say, well, to bring something like consciousness into the theory. So they have devised, or tried to devise, some ways of getting it out. I mean, instead of saying that consciousness has something to do with these events, they say, well, the events are spontaneous, and you have a number of, or you have one well-known theory that just says there's some conscious, there's kind of, every once in a while an event happens that just by itself collapses things, and this is just described without any reference to consciousness. There's a theory by David Bohm which says there really is, in spite of what quantum theory says, there really is this well-defined trajectory underneath it all. And now, in both cases, people who have tried to really pin these things down have not, in the end, reached a satisfactory resolution of these things that matches all of the relativistic requirements. In other words, the requirements of relativity theory have prevented any thoroughly adequate solution along those lines. And but you know, there are new physicists coming up and trying to invent new and more complicated ways of essentially denying that consciousness has anything to do with it. And now, I don't know why they should want to do that myself. I mean, why try to say that we're robots? And it doesn't, to me, have a rational explanation. I mean, a reason for them to do it, but they keep trying, and that's all I can say. And to me, the founders had it right when they said, really, we should look at the structure of the theory as it works in practice and how it is applied in practice. And in practice, it really is about relationships between experiences. And this fact that I'm emphasizing here, how the quantum Zeno effect actually allows you to understand in a mechanistic way, just using the equations, how a conscious effort could influence things. People listen to seriously, and I get a lot of not very much negative feedback to that idea.
But computer science, see, one way to answer the question, which gets into the beginning of the many worlds interpretation, just to show the extent to which people are willing to go to get consciousness out, and to answer your question, why would people do that? Well, if you're invested in saying that the brain is just like a computer, and you can understand, especially in this particular geographical area, why somebody might see there's, reason to see financial gain in holding that view, etc. I mean, if you really are committed to the position that what we need to do is show everybody that the brain is just a computer, and by using computers we can model the brain, and all this issue of computational neuroscience and why it's become so popular and why there's so many journal pages contributed to computational modeling of the brain. I mean, what does that tell you about the brain? That you can model it on a computer. Why is that called neuroscience? I mean, that makes no sense. But hey, it makes economic sense, it makes financial sense, it makes philosophical sense if what you're trying to do is save the materialist worldview. Why would you want to save the materialist worldview? Because it gives the illusion that there's an elite up here of experts who know how everything works. The fact that it's the Wizard of Oz, well, the regular people don't know that, so let's, do the Wizard of Oz thing. I mean, it's like, so the computer people have a lot of complicity with this. I mean, they're driving a lot of it. If you're operating under the model, which I don't think is a reasonable model at all, but there be it, it's not hard to understand why they advance the position that the brain is a computer. Then you get the many worlds people, because in artificial intelligence, the many worlds interpretation seems convenient. Address that. He doesn't want to, but he can.
Well, the many worlds approach is another one, which just says that everything happens, that we only think, our own experiences follow a particular line of events that are discrete and distinct in some way, or at least they don't smear out the way that the quantum probability function smears out and covers a large range of classically distinguishable possibilities. And so, and again, the many worlds theory, its publicity is greater than its achievement. I mean, there are a few people that will go along, and it's got a lot of good press. But the people who even talk about it, and when you talk to them, I mean, they're not this. They don't understand. They don't answer. They're not able to answer. You don't have a well-defined many worlds interpretation. I mean, there is.
What percentage of people at quantum computing conferences say that the many worlds interpretation is the proper understanding of quantum mechanics?
Yeah.
I'll repeat the question.
Yeah.
What percentage of people at quantum computing conferences say that the many worlds interpretation is the proper understanding of quantum mechanics?
Do you want to say it once more?
Nah, 2 is enough.
Well, yeah. If you go to
the answer is about 80. About 80% of people at quantum computing conferences say the many worlds interpretation, which doesn't work, is the proper understanding of quantum mechanics.
And so,
you think money has anything to do with that?
So, but the other point is, these are people who are going to quantum computing, and they're not basically physicists, most of them. If I ask around my department and the people that I talk to at the radiation laboratory, none of them believes in the many worlds interpretation. So it just depends on your sampling of people. And this
sampling
particular
error.
sampling,
there's sampling error for you.
If you talk about that particular sampling, then
that's an influential sampling, and it's very influential on neuroscience, because artificial intelligence has an inordinately large effect on the funding decisions that are made at the NIH about neuroscience. Is this still being recorded? I hope so.
So basically, if we ask not only kids but like grown-ups to draw an atom, they would still draw the old like solar picture 100 years after the quantum model kind of refuted that. So my question is, like, when is this whole like new way of thinking in neuroscience and quantum mechanics, and both of them together, be a part of like basic education?
Well, I'm taking what I hope to be the rational approach, and Jeffrey thinks this is not going to work. That just being rational about it is not going to.
Let's just say its track record isn't great.
But
and we're going to be experiential here.
In any case, my own approach to this problem is just try to explain to people and let them see which is a more rational position to take, and I hope that eventually more and more people will understand it once they hear it.
But it's got to be the younger people. I mean, you know, it's like, as I said, I mean, I don't know how much you guys know about, like, you know, the celebrities of this question, but the celebrities of this question are all the way on the other side of from where we are on it. And, you know, I mean, swine flu or not, I imagine if Dennett was down here saying that consciousness doesn't do anything and doesn't even really exist, we probably might have had a bigger turnout, et cetera, et cetera, et cetera. So yeah, we're up against, you know, there's a culture war. We're in a culture war. And, you know, everybody's got to make their own choice about the role they play in the conflagration of the times in which we live, or anyone lives, you know? You got to make choices, because at least everybody in this room probably by this point believes at least we have the capacity to make a choice. That makes us a small minority among scientists.
But yeah, I think in the end, people are going to not go along with the idea that they're robots. I mean, that their thoughts have nothing to do with their behavior, and that these thoughts that we have are just something that are thrown up and don't do anything. And it's so foreign to your whole way you live your life, and
do you know
you can't actually believe that.
Or when did you stop looking?
You can't actually believe that. No, you can't really believe it in the end. In fact, most of the words that we hear here are essentially going along with the fact that our consciousness is doing something, and but there is this
I like him because of his sunny disposition.
There is this respect for publicity has a big part to do with this. I mean, there's a word out there that says that we're not conscious, and the scientists say we're not conscious, and therefore people...
and they put it on the cover of Time magazine, but otherwise it has no influence at all.
Yeah, and yet, I mean, even... Yeah, do you have one more question? Yeah.
I could probably reject just as easily, but... So yeah, I mean, thanks for the talk. I really appreciate what you guys are saying. It's very interesting. I've been interested in it for a while now, but I've never fully understood how consciousness or intention can, say, you know, collapse a quantum wave function. So does that have to invoke some other dimension? You know, I mean, we're not obviously putting consciousness in some three-dimensional Cartesian space. You know, we're saying it doesn't reside in the brain, I'm guessing. So does that invoke some, you know, micro dimension, macro dimension? These are things that I've never quite understood.
Well, the way quantum theory is formulated, I mean, there are variations of it which go into many dimensions, but it is formulated in four-dimensional space-time, and you have this objective, mathematically described, evolving state of the universe, which is evolving according to mathematical rules. So it's very well defined, and that's a deterministic evolution most of the time. And now and that was the problem that quantum theory faced at the beginning. If you look at the equation, you just see that it's generating always more and more of these possibilities that are incompatible with our experience. And so the answer that quantum theorists came up with is, well, really what science is about is making predictions about experiences. So all we have to do is just understand this mathematical procedure in the actual practical context that we want to use it. And in order to do that, you just change your idea of what the mathematics is representing. I mean, mathematics could represent this or that. And the bottom line is that the quantum theorist says that the basic, or this is the orthodox view, that the basic things in nature are these events. And these events are supposed to have both a psychological and a physical side to them. In other words, they have an experience, but they are reflected as a certain change. You know, if you have an experience that you now have new knowledge, of course, your expectations about the future are going to change. And your expectations about the future are represented by this mathematical substrate. This mathematical substrate is not representing a material thing, because all it's representing is expectations about future observations. So it's just a matter of shifting your point of view and saying, yes, we have a well-defined mathematical foundation and it's evolving according to objective rules, but what is it, what is its nature? It's not a material thing because it does these sudden jumps. So you just change your idea of what the mathematics is all about. It's not about a material universe. It's about experience, basically, and how experiences fit together. So, the point is, that's how it's actually used by quantum theorists. I mean, when you're taught quantum mechanics, you're taught about, designing an experiment such that it will inform you about the answer to some question that you're interested in. And it's just a matter of saying it wasn't about matter in the first place. That was a mistake. It's about experience is what it's about, and that's how it's actually used in quantum mechanics, and that's how it's really taught. You don't somehow maybe say it that explicitly, but that's really how it's taught in quantum mechanics courses. You're taught as this is a procedure for making predictions about what your experiences are going to be on the basis of earlier experiences.
Yeah, I understand the idea that it could be applied to any dimension. I was just trying to figure out, I've been always trying to get my head around the fact that in the end, what you're saying is that in the case of ions, that it's collapsing down to a very specific four-dimensional state, three spatial and one temporal point in what we would, classically conceive as reality.
That's the important point. It never collapses to a point. I mean,
right, because it's continuous and it's always.
I mean, even think of a photon. Right. A photon is coming along, and maybe there's a silver bromide ion someplace, so it never goes to a point. You have a counter that has a certain size, and the counter clicks, so it reduces to something that may spread out over miles or feet or yards, and it suddenly jumps down to something that's smaller, but it never goes to a point. And this smallness, where it's localized, has to do with what you see. In other words, I see this counter is clicked, so now I know that I have to understand this in terms of it's not out there, it's not out there, it's in the neighborhood of this counter, and you have to formulate the rules for exactly how it's collapsing and what the smaller region is. But it has to do with what you want to have it to do with, and what it does have to do with is your observations. I mean, it's what you've now learned about the system, and Heisenberg is quite.
And so I guess I'm unfamiliar with how people have shown that these ion channels behave are best described by quantum mechanics as opposed to some other probability distribution function, a Gaussian or a von Mises or something like that.
No, but the point really is, and I'm not sure if it was.
Because I guess I'm just getting down to the point of observation.
Really good question.
No, the point is, you have this evolution. Now, nobody is looking at the ion channels. Every once in a while, you might take a picture of them, in which case, that's your observation. But generally speaking, this is all going on without a lot of experience associated with it. And if you just let it evolve, due to the uncertainty here at the level of the nerve terminals, and then see how it evolves in the brain until an experience occurs. Now, an experience is a huge thing. I mean, it deals with huge parts of the brain. So the whole structure of the brain is a hugely complex structure that is represented by a smeared out wave function that's got all sorts of potentialities and possibilities in it. So according to quantum mechanics, it collapses when an experience happens. And the experience, there could be a huge, if your experience is the experience of deciding to raise my arm, in this model that we're talking about, there's a large region of the brain which we identify as the pattern of neurological activity that if you actualize it, would send out these pulses that eventually cause my arm to do something that I want it to do. And so the collapse is not down to a point, or not usually even down to a very tiny thing. In this case, the collapses are really to huge, to things that are centimeters in.
Yeah, macroscopic action
templates. A global state.
That's how we can get back to classical neurophysiology.
I've always understood the brain as resting in a metastable state, and so that you
bingo.
It's just an emergent property.
That's it.
Thank you.
And microtubules are other types of like parts of the cell machinery that are subject to intensive quantum effects, right? And like one question for Jeffrey: why is jazz important for having a good talk?
No, but do you want him to say something about Penrose? I mean, that sounds like you wanted him to say something about Penrose.
Well, definitely. Yeah. If there's any comment
Roger
to it.
Penrose.
Did he say Penrose?
No, he said microtubules. Isn't that Roger Penrose's middle name, or at least?
But if there's any comment,
no. I mean, obviously we don't want to say the other guy, but okay. But
Hammer.
I mean,
so what is your point? What is your question?
I just said it. It's like microtubules are like also sort of nobody knows what their function is in the cell, but I mean they're like multifunctional, but there are also like quantum effects involved.
Well, Roger Penrose developed a certain hypothesis as to when these collapses occurred, and so he and Penrose created
Hameroff and Penrose
created this model that